Okay, so let's do another application um, of direct, not direct product, but um, of our previous lecture concerning polarization. So instead of thinking of the vectors this time as polarizing a person to either be male or female, this time let's say that it is the amount of effort that's put into trying to rizz someone. So the measure of rizzing someone, and let's suppose that the transpose of the second vector that we're gonna take the dot product with the previous one, the measuring device only allows this certain percentage of this and that. So grab your calculators and let's do this thing. Okay, so let's assume that the measurement of an effort can be written or expressed as a ket vector. It could be 1, 0, it could be 0, 1, or it could be some measure between those. So it's this time in percentage. So 100% will precisely be the j hat vector, or this is I hat, and then this one will be j hat. Okay, so let's set up our measuring device, and the door. So I have my friend Chen here. Oops. So I send him through a machine that forces him to exert this much effort in trying to raise a girl. And then I send him next to a door, or I present him to a door that's hooked up to a machine that detects exactly how much effort he is exerting. And let's say that, okay, so let's set up our door, I'll call it D. So let's say it only allows Chen, or my friend, to go through the door if he exerts 100% effort in trying to raise a girl. So I suppose we're going to set our D here, which is the transpose of this vector to be this one over here, 1, 0. Okay, so let's say we put Chen through this machine, and the machine polarizes him or forces him to exert 0 effort in trying to raise a girl. So let's say he uses these like terrible or shitty one-liners or shitty pickup lines and hopes that the girl would like him. So let's see what the result is. Let's see what happens here. Okay, so I asked the machine to only allow Chen if he exerts 100% effort. And I hat here measures 100%. And j hat here measures 0%. Okay, let's do the experiment. So we're gonna take the inner product, or the square of the inner product of these two vectors, or this one here, since our primary state is j, which is no effort. So let's do the experiment. Okay. So the inner product between d and v, or let's call it j. Get vector I. Take the square of that in order to obtain the actual probabilities instead of just the probability amplitude. So we get the square of 0, 1 dot 1, 0 squared. And then just multiply or take the sum of the products of the entries. So 0 times 1 plus 1 times 0 squared gives us 0 plus 0 squared, that's 0. 0 squared, and that's 0. And that shows us that the door will absolutely not open, because since we only allowed it to open the door when my friend exerts 100% effort, it won't open it because my friend exerts 0 effort in trying to raise something. So yeah. So it can not only be thought of as um, allowing certain genders to go through a door or gender identities, but it can also be a way for us to determine probabilities that the door will open for someone with a certain amount of riz, or at least amount of effort in trying to riz someone. Okay. So let's do the inverse case, and this time say that my friend exerts 100% effort in trying to riz someone. I mean, I know my friend exerts more effort than what is needed. He exerts more than 100%. But let's just assume that he's just 100% because we can only confine our probabilities to 100% or between 0 and 100%. So this time instead of j hat, this time instead of j hat, we're going to be using I hat. You take the inner product, square the inner product of these two vectors to do our experiment. Morning, Kyle. Talking about Chen again. We're talking about Chen again. With relation to the last lecture. Okay. So square of the product between this and this one. So 1 0 dot 1 0 squared. And that gives 1 times 1 plus 0 times 0 squared, 1 squared is 1. And just multiply that by 100 to get the actual percentage. And you get 100% chance that the door will open up for my friend. Because according to our primary instruction of letting only people who exert 100 effort or 100% effort in trying to risk someone, it's going to open for him. 100%. Now let's say my friend, Chen, only exerts 50% effort in trying to risk someone. Like, he's not exactly going to use shitty one-liners or shitty pickup lines, but he is going to use a decent one. A decent one, but it's still kind of shitty in the eyes of the girl. Let's do that experiment. So that would entail, or how would we get a 50%, or how would we represent a 50% vector here? If I hat here, or this vector here represents 100%, and j hat represents 0%, then surely it would be a vector that makes a 45-degree inclination from either axis, the x or the y, the vertical and horizontal. So a 50% effort in trying to risk a girl would be halfway between this vector and this vector. So yeah. So 50% implies a certain vector, which I will call I'll call f. Oh no, not f. Let's use something else. Bar phi. Yeah, bar phi, which is something. So recall our trigonometric relations or trigonometric identities we want to do and try to represent or convert from polar coordinate system to rectangular coordinate system. Cosine of 45 degrees and sine of 45 degrees. Because we want it to be balanced. We want it to be halfway. We want to bisect the angle formed by these two vectors. And this is where you break out your calculator. I know I'm supposed to remember this, but yeah, that is 0.71, and sine gives 0.71, as it should be. It should be balanced. They should be the same value over here because we're practically bisecting an angle, right? So an angle bisector gives equal dot products of the vector with respect to the x and y axis. Okay. So it's 45, 0.71, 0.71. Okay, with the same instruction at the detector, let's perform the experiment. So let's say that my friend only exerts 50% effort. Let's do the experiment. So instead of I hat, this time we have bar phi. Bar phi. So the square of 0.71, times 1 0 equals. So it should should give us a 50%, right? It should give us a 50% because he only exerts 50%. So he is polarized only halfway, right? So only, and since we are 100% polarized, so vertically polarized, it should be that only 50% of the light particles that pass through that should be able to pass. So yeah, let's verify that experimentally. So that would be E 0.71 plus 0 squared 0.71 squared, and actually squared gives us indeed 0.5. Multiplied by 100% to give us 50%. So the door will only open halfway. So it's gonna, if the door travels in a 0 to 90 degree arc, or 0 to pi over 2 radian arc, it will only travel halfway before stopping. So it's not going to completely open for him, but it will open just enough for him to peek through. So yeah, what we're basically doing is trapping Chen into a room and then letting him out based on how much he puts effort into raising someone. Yeah, okay. There. So we verified through our system that indeed it will only happen halfway before stopping, and it is only because that Chen only exerts half the effort to try to raise someone. So yeah, I already have a video on my channel. You don't need to film me. Okay. So now let's do an unbalanced percentage here. Now give me a percentage.
Higher or low?
Give me a percent. How much effort you use?
36.7.
36.7? 36.7 it is. Okay. So 36.7. That's 36.7, right? Oh, guys, if you don't mind. Simon. If you guys don't mind. Talk outside.
Ask this guy. You were quiet when you were here.
Okay, so let's do 60 what?
36.7.
36.7%. So 36.7. 36.7. How do we do this? So I suppose we divide. We have one that goes 36, so one that goes 36 degrees, 36.7, and then 90 minus 36.7 gives us 53.3 degrees. So this implies I'll use psi this time, psi, no, not psi, that's the wave function. Let's use phi, 1, which gives us the cosine of 53.3 degrees and sine of 36.7 degrees. Okay, so it can be switched, but we're going to assume that the 53 degrees is with respect to, So we want it to be in the best interest of, we want it to be in our best interest that Chen gets out of this room alive. So yeah, we're going to make the angle shorter with respect to this, so it has a higher probability of opening for him. Okay, so now we have set up our vector. I hope this is correct. So just take the cosine of 53.3. That's correct. So that's 0.60, and the sine of 36.7, 0.60. That's strange. Oh, nonetheless. Okay, so let's perform the experiment. Phi 1. So we force him through the machine. It forces him to only give 36.7% effort in trying to raise someone and present them at the door in the detector machine. Okay, so the square of, let's see, the square of 0.61 dot 1 0 gives us 0.61 squared and 0.61 squared gives 0.37 or 37%. All enough. So the door will only open 37% of the entire arc. So that would be around, if the door would only swing 90 degrees and it's completely open, it would only swing 33.48 degrees, or if we convert that to radians, from 80, 0.58 degrees radians, or 0.58 radians. So yeah, application. Using some different concept, but we use the same system.